Hi everyone, welcome to our webinar Free DB Faceoff MySQL versus Postgres versus SingleStore free tier. The session is perfect for developers, database administrators, and tech enthusiasts in general. You can explore performance, scalability, and unique features of these three popular database options. And our expert panel will conduct a comparative analysis of MySQL, PostgreSQL, and SingleStore's free tiers. I'll let the experts obviously talk about it. So joining us today is Mr. Madhukar, who is our CMO and also a technical evangelist here at SingleStore. He has been a very regular speaker at our webinars. So if you attended yesterday's webinar, we had Akmal, who did a very amazing session on fraud detection. So thanks, Akmal, for that. And thanks, everyone, for joining. My name is Yukti Dwivedi, and I will be your moderator for today. If you have any questions, any feedback regarding today's session, feel free to drop a message to me on LinkedIn, or you can reach out to anyone else on the team. Again, this will be a hands-on session, so you can take up any questions in real time using the Zoom Q&A button, which is present at the bottom of your console. So we will be taking up all the questions that are thrown at us, and just make sure that you don't use an anonymous ID to ask the questions, because we don't take those up. And Akmal, do you want to talk about the notebook, that the getting started on SingleStore notebook? Just a quick note for everyone, I will be putting the links to everything that I'm talking about in the chat. We will be doing a raffle. So anyone who signs up for SingleStore notebooks and tries it out today during today's session, we will make them eligible to be entered and be entered to win branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. It's absolutely the winner's choice, and we will notify the winner by the end of day via email. So make sure to try it out, and Akmal will it's either going to be me or Akmal. We will be putting the links in the chat about the notebook and a link to take you to the free trial. So thanks everyone for joining, and Madhukar, please take it off.
Thank you, Yukti, and good to see you again, Akmal. All right. So if you have ever attended one of these webinars, at least the ones that I do, then you probably know that I'm not a big fan of PowerPoint or Google Slides for that matter. I like to, I miss the time when we are all in person and we are in front of a whiteboard. So I try to emulate that with some diagrams, and then mostly show and tell. I like the idea of just showing stuff, just like Akmal, versus just talking about theory. So today I will go through some of the explanation, and then a majority of the time will spend in comparison, because I do want to show some real world data and use cases. So a little bit about myself, I did start off my career as an engineer or a developer. And the first job I had as an engineer was a SQL Server developer. So I used to write store procedures for Microsoft SQL Server, and that would run for like 15, 16 hours. And after a while, then it would give me an error. And then I would come back in the morning and debug it, fix it, and rerun the whole thing. It was a very painful process. But eventually, from being a SQL Server developer, I started moving into the front end, first with PHP and then with Java. And over a period of time, I think it's a very simplistic view right now. But even today, when I build out an application, it kind of sort of looks like this diagram on the screen. So you have a backend. The backend typically have either API endpoints, or it's some sort of a service or an aggregator that returns data to the front end. And the front end could be, it's mostly these days it's React, but it could be a bunch of other frameworks that you might be using. And the backend sometimes will also call other services in the organization, or it could be external APIs within the internet. These days, like everything has a webhook or an API endpoint. So sometimes your front end would also call an API endpoint as well, but let's stick with a very simplistic view by stripping down what a end-to-end application looks like today if I were to build it. So from that perspective, and Yukti, I'm not on my screen, I don't see the questions, but if they do come in, maybe it's up to you if you want to get those answered in the end or we do it while we are talking about it. I'm fine with either ways. So ultimately, what you do is you build this front end, and they are independent because you want to, do independent releases for each one of these and also independently scale. So there's modularity and scalability why you would do something like this to begin with. And then you choose a database because let's say if you're building an e-commerce platform, like the most common example, then you would have users, you would have product, you would have even maybe the line items for the product and the payments and so on. So you start with something like this, and you end up with a database that is one of these two, right? So let me explain this. And I know there's a bunch of people who are expert in this, but for those who are not, let me just explain what this is. So when you look at a MySQL or Postgres, it's just like a Excel table. And the Excel table has both rows and columns. So you define the rows, you define the column that, okay, I want user name, I want user email, and a bunch of these columns. But then as it grows, you have multiple tables, and these tables have columns that can relate to each other. So now you build an entire schema that you can, that is relational. So that's a classic rows, columns, relational database. But a lot of developers actually love MongoDB because it's typically what it would be called as a semi-structured. So this is structured. This is semi-structured because I might have a property and then a value. And this property and value could be different for different documents. So maybe for one user, I have more details. For another user, I don't. And if you're using JavaScript, so this is like a JSON document or a JSON object, from a front-end point of view or even development point of view, it's easier to build into something like this and then just drop it. So over a period of time, hopefully your application becomes successful, or if you're working in a corporate setting, they become bigger and bigger because you're writing more data and you're reading more data. So what tends to happen is you do a lot of these things which are point read and writes. So point read and write would be select, this is a read, select this row or find an object where the user ID equals this, so username is equal to these. And these are simplistic. So these reads are extremely fast because of all the things that has happened in the world of databases. We're talking about a few milliseconds. And sometimes when the number of rows or the number of documents become extremely large, what you can also do is you can add something called an index. So index would be, okay, for this specific column, I'm going to use this quite frequently to do queries. So let's put a quote unquote index in it so that the result is always faster. Now, obviously, as your application develops, you also want to start doing a few inserts, or you might want to update. Like a user goes into the profile and they updated their address, or a new user comes in and you do insert. So those are point writes, and that also is fairly okay till a certain time. Now, when you do an update, that's when things start to go a little bit off the rails when you have a large amount of data. So what is a large amount of data? And for me, I've seen my experience is if you're using MySQL or Postgres, anything over 10 million is where you start hitting issues with either updates or maybe even a delete, a specific delete. And why is that? Is because typically what you do is when you run a query, you do a full scan, and it gets a lot worse in a JSON database when you do certain other kind of queries, which I'll talk about. But you do a full scan and then you do an insert. Now, there are ways around it. You can definitely scale out where or actually for MySQL, what you do is you basically go in and only increase the size of the MySQL VM. If you add multiple databases or nodes, then you have to figure out, okay, which data lives in this node, which data lives in this node. MySQL is typically what is called a shared nothing architecture, and we'll talk more about the clustering portion of it. And so the difference between MySQL and Postgres is in the SQL that is used. It's slightly different in the syntax. There are a few other features which I'm not aware of, but more and more people use Postgres these days versus MySQL is still used a lot, especially with WordPress and such. But Postgres is becoming very common, and MongoDB is massive, right? Like everybody uses MongoDB at some point or the other. Now, a lot of the times, what you want to do is if you are building this database as a developer, you don't like to mess around with the database. I don't want to go in and start creating schema, think about all the different points about how do I optimize this query and all that. So there are also things like what is called an ORM or object relationship mapping. So think of them as SDKs or think of them as libraries that you embed in your backend or wherever you're running the queries. And you look at the table as an object, and within that object, now you can do a get method, post method, things like that. So you're just using the language of your choice to talk to it. And then later on, when you change the database, you can change the connector. And then, of course, there's some change, but you're not rewriting your entire language. Same thing with MongoDB. So in the world of JavaScript, the two big ones, or actually three, there are quite a few, that is often used is, of course, Hasura, but there is Prisma, which is pretty massive, and Drizzle. Drizzle is also one of the big ones. Interesting fact, SingleStore has a Drizzle connector, which is about to go GA, and Prisma is what we are working on. The thing about MongoDB is if you're using MongoDB with SingleStore, it works out of the box. Like we just change the connection string, and then all the queries that you're running will work against SingleStore as well. But we'll get to that in a few seconds. All right, so now when your number of rows or number of documents start to grow, this still does exceptionally well, but this starts to struggle a little bit, especially when you scale. Now, when you start doing, let's say, vectors, because you're building an AI-based application, and in an AI-based application, you might have unstructured data. You might have PDFs, you might have file systems. You want to convert it into a vector, which is basically a bunch of floats. And then you want to run some sort of an algorithm on it to find a semantic match, like a dog is close to, husky and canine and so on. So for that, now almost every database, except for MySQL, has vector enabled in it. So if you're using Postgres, there's PG vector. If you're using MongoDB, they have a vector index. So you can take the same database and now you can insert the vectors as well. Now you do have to take the unstructured data and convert it into vectors using some sort of embedding model. But you can store that and search against in pretty much every database except for MySQL. But if you're using MySQL, now there's also another choice. You can go in and create a brand new vector-only database, and that could be Milvus, VV8, Pinecone. A bunch of these are now available, but they only do vectors. And so that's where you run into, now moving the data between the two and latency because you're doing certain queries in a different database, then you're trying to combine it, and this becomes more and more complex. So one thing you try to do when your scale goes up is, let's see if I added this. You now start to add a caching layer. A caching layer is, okay, I'm running this query multiple times, or several of my users from the app are using this same query over and over again. So I need to cache it in memory, and memory is orders of magnitude faster. So what you tend to do then is you tend to use something like Redis. Redis and Memcached are the two big in-memory caching solutions. And you can also use it for session management. So if I'm logged in, then within that same quote unquote session, everything I do is persisted and it becomes faster and faster over time. So caching is a whole different world and a whole different, in a way, science by itself, where it is different kinds of caching. LRU is last recently used, and there's there are a bunch of things that goes into it. But Redis typically is the choice because it's in memory. Now, Redis also has a way to persist that to the disk. So next time when somebody comes in, you can go take that and then bring it back into memory. But Redis is mostly key value. It's not a SQL table or it's not a structured, it's key value. Now, there are other modules and stuff, but primarily it's key value. And it works great if you're using a programming language as JavaScript because, again, it's a very friendly to a JSON object. So now when you want to run additional queries, things start to, again, become a little bit unruly, and you start to think about other things that you add. And as you add other things, leads to complexity, more data movements, your releases become slow, there is more complexity, always causes more overhead. So at this point, what I also wanted to do before I get into anything else, let's talk about a third option, which is SingleStore. And SingleStore, of course, I'm biased because I work for SingleStore, but I do want to call out a few things of what is different and what is similar to these three things when it comes to SingleStore. First of all, it is wire protocol compatible with MySQL. So anything that you do in, or at least 98% of anything that you do in MySQL will work with SingleStore off the bat. So you create the tables, you have different keys, and you can do group by and join. The one biggest difference between MySQL and SingleStore is that SingleStore doesn't do foreign keys. So inside of MySQL, you can define a constraint and say, hey, this column is a foreign key for this column of this table. Within SingleStore, that is managed at the application level because independently it scales up, and I'll talk a little bit more about that. But one of the key things that happens with SingleStore, actually, before I get to that, there's one other thing I want to talk about, which I did. So the other query that you start to run is you would say, okay, now I have 10 million rows of orders, and there's a number associated with it or a float associated with it or whatever. There's some sort of a number associated, which I'll show in a second. Now you want to do average. So let's say you want to say in that e-commerce thing, show me the average of the orders by the customer, and then order it by descending value of that order. And so there, the query now becomes you read all the values of that column for that order, and then you calculate the average, and then you do another query to figure out which one is the highest, and then you group by certain values. So now you're doing analytics. Now, it turns out that analytical queries work really well when the architecture of the database is flipped, where the values is not stored in rows, but it's actually stored in columns. So when you store it in column, and don't ask me what's the math behind it, but it's when you run average, sum, group by, and so on, it's order of magnitudes faster. So that's a columnar storage. So columnar storage would be, Vertica. There's a bunch of what is called an OLAP database, or online analytical processing. And these are considered to be OLTP, or online transaction processing. Transaction processing is read and write, so extremely fast, but analytics is in a different database. So now you've added maybe a vector database, but you've also added maybe some other data lake or something bigger, BigQuery or something like that, where you're now moving the data there and you're running analytics. But over a period of time, as your number of rows even there increase, your analytics becomes a bad job, which takes a long time. But if you ever have to update it or delete or do any upsert, then God help you, because columnar database is not good for read and write. So the reason why I bring that up is SingleStore started off as an in-memory MySQL compatible database. And so it was called MemSQL. It was 11 years ago. And then we changed the name because we got a patent for an architecture where we built an algorithm to take the data that's in memory and only keep it in memory if that data is being used constantly by the application of the user. If it's not, based on the algorithm, it goes to SSDs and NVMEs, which is your local disks. And if furthermore, if it's not used at a lot, then it goes to your object storage. So the object storage in the cloud world would be an S3 bucket, Redshift, there's so many, or Google buckets and so on. Now, when it is in memory, it also has what is called skiplist indexing. And I'll let Akmal talk more about it if you have questions, because I'm not an expert in that. And there's another thing called inverted index, or IVF, which makes this incredibly fast. So now it is like we're talking about milliseconds. So now you're doing these read and writes at the speed of maybe what Redis does for key value. So orders of magnitude faster than MySQL or Postgres or even Mongo, and I'll demonstrate that. But when it comes to queries, what we also do when it comes to analytic queries, what it also do is when the data is created, we store that copy of that data both as a row-based, but also as a columnar-based. And now when you do a query, what we tend to do is figure out, oh, is this an analytical query? And if it is, it actually goes and grabs that data from the columnar storage. And the columnar storage is, of course, much faster. So that entire thing that we do is called query plan. And the query plan basically is independent of the data itself. It's based on the query. So it has its own algorithm to say, okay, this one I'm going to go to memory, this analytics I'm going to here. And to the user, it's simplified because it's straight up a straight, simple SQL. And the SQL does the magic underneath. Now, if you choose to take certain data and say, no, I only want it to be stored in columnar, you could do that. Or you only want it in row, you could do that. But by default, it's the engine that makes the decision. And then when you want to expand, what you could do is every cluster has an aggregator and what is called a leaf node. So unlike a shared nothing architecture, here, when you create a table, you could say, hey, this table has a quote unquote shard key. And the shard key basically tells the database or the engine that any shard key that's the same, or the data where that key is the same, store it in the same leaf. So basically, instead of copying that entire thing across multiple nodes or leaves, and then having the aggregator decide which one to go to, and removing the latency of copying it everywhere before you do the return, now it's smartly distributed. And for certain things, it goes in certain places, certain thing it goes somewhere else, and it's distributed by shard. It still does replication, it still has high availability, but just keep that in mind. And then the last piece that we did was we separated where you run the queries with where the data is stored. So it's the separation of what is called compute and storage. So what that basically means is if I'm running a very large query and I know it's going to take a lot more processing, I can put that as on a bigger machine. So we call that as a workspace. I'll show that as well. And then eventually, over a period of time, in the last 11 years, we not only added row-based, columnar-based. 2017, we added vectors much before the world was taken over by AI. And then we added support for JSON. So like I said, now the MongoDB APIs are supported, 95% of it. we added time series, we added geospatial, we added binary JSON. So any data type that you can think of, you can most likely store it in SingleStore, except for graph. It's not a graph database. And the other thing that you could do is you can now search across that data using either an exact keyword match, which is what is called a lexical search, or you can do a dot product, which is a semantic search, or you can, even in the semantic search, there are different algorithms. So you could do like exact KNN or approximate nearest neighbor, and you can combine it, but it's all in one table, which means I'm not bouncing around much of different places. In one table, I'm making the query to do read, to do write, to do upserts, to do average, group by, and vectors all in 1 second. And because of this architecture, it's extremely hard to believe. I was skeptical too. Now you can do this across petabytes of data in a few milliseconds. So this is not just pie in the sky. If you look up at some of the resources, I'll let you go do the research on your own. You can find out all of this, all of these existing customers, even on Twitter, people who have gone from one to the other, and they've seen like 400 times faster, 800 times faster. And the big difference is that's also cheaper because you're using fewer resources to run the same amount of queries. All right, so enough talk. Now let's get into some actual hands-on. So what I wanted to show here is, if you can still see my screen, on the right-hand side, I have SingleStore, and these are my tables. There's customers, there's line items, there's nation, orders, part supply, region, and supplier. On the left-hand side is Postgres. Now, with Postgres, there are a couple of places where you can go and quote unquote buy Postgres. This one is called NeonDB, and I will show that UI as well. But there's also Superbase, and Superbase is the open source version, which also gives you authentication, a bunch of other stuff. But you can run Postgres on any cloud provider, which includes Google, AWS, and others. So this is, because both MySQL and Postgres are open source, you can pretty much run it locally, you can run it on your own, or you can go to one of these services and they will happily take your money to provide you additional services. So the example that I wanted to show is NeonDB. Fun fact, the founder of NeonDB is also the founder of SingleStore. So here, think of it as more of, I would say, a serverless database. In the sense, you don't really go create a server. If you are a developer, you have this organization, and then you have this project. And the neat thing about this is that you have what is called branches. So there are multiple different branches or different snapshots of your data. And then you can take, which is kind of my understanding of their database, but you don't really see that. And then you can start running queries here. But we are going to run SQL queries. So I'm going to leave NeonDB here. You can go check it out. There are a bunch of other places you could try it too. All right. So now let's get to SingleStore. If you go to SingleStore, singlestore.com, and you say start free, you can sign up for free. But I am going to sign in because I already have it. The one thing I like about SingleStore is that if you're a Python developer, you can actually go to singlestore.com/spaces. And Akmal has written a really neat Python notebook that gives you everything as easy as possible. And I believe that one is called, Akmal, help me out here. Is this called Getting Started?
It's getting started with SingleStore, Maduka. If you can just search in the left box, you might be able to narrow it down.
Okay.
That's the one.
Thank you.
That looks like it. Yeah.
So here, what you could typically do is you could just hit try it now. And if I do this, I can just log in. And once I log in, I'm using my Office account. Okay, once you log in, now the notebook opens in its own container. And this, you could do this in a free account too. And now you have everything in one place. So you can say, hey, show me, when you sign up for free, you only get one database. But if you upgrade it with free credits, then you can get multiple databases until you use up that, I believe, $600 of credit or something. So this by itself gives you everything that you need to get started. There are two things you could do. You can either create cells, and that could be Python, or you could do SQL. And if you do SQL, you can choose the database from here and just run your SQL and it will run. Okay. So this is one neat part, which I would highly encourage everybody to go get started with if you are looking to get started with SingleStore. It cannot get easier than this. And what's even better is that you could say code with Squirrel, and it will, this is a AI bot that we created, I think about 18 months ago. And over a period of time, it's gotten better and better. And it is trained on SingleStore itself. So you can give it a query and say, optimize it, or you can just say, give me the SQL, you can take it, and then you can just add it to a cell and run it. But what I wanted to show you was this thing that we will be testing against Postgres. So remember I said the compute and storage are separated. So this is the workspace that I have. And then in the workspace, I have a bunch of different databases that are attached to this. Now, when I'm done with this, I could just say terminate, or I could resize the workspace. I can, pause it, or I can also have a setting where I could say, hey, auto-suspend it when it's not in use. So you're not really paying for it when it's not being used. And the performance one, I think I had created with a higher CPU and so on. I think it says 0, maybe not. But I could potentially also change the the CPU on it as well. I think I need to start it before I do it. So now what I wanted to show is that this is the database. And now if I want to connect with it, I just go to connect and I can say SQL IDE, or let's just use SQL IDE. So it gives me the host name. It gives me the port it's running under. It gives me the username and password and the database name. Now the password, you can go to access and reset it. So you get the user ID, password, and all the other details over there. Now, what I wanted to do is to first show you this other notebook. So if you, and actually I'll share it. So if I go back to this, and this notebook is called TPC-H performance, optimized performance. It's also in spaces. And what it would do is it will create the database for you. It creates these pipelines and will inject those databases with tables as well as actual data. And then it shows you that, hey, if you run it, this one takes 8 milliseconds, but some of these queries, as you start to do, it takes longer. And then it says, okay, now let's create a shard key. And then you run the same queries. And now suddenly you're getting responses in a lot less time. So all I wanted to do was to grab that data, because it's a massive database, right? With massive amount of data. And then I wanted to run queries. And the thing I like to do is there's this tool called TablePlus. TablePlus has nothing to do with SingleStore. It's a SQL client. I like it because it's visual. Plus, I can run my own SQL on it, and it gives me the queries. But the other thing that I really like is when I, let's say, I can visually change the structure of that data. So if I go to, let's say, this table, and then I say, show me the structure. These are the columns, these are the keys. And if I want to add a new one, I can just go and do this here versus me putzing around with SQL, which has become extremely rusty over a period of time. So now we have these two data bases. Let me just remove this again so it's cleaner. And so, oops. So what I wanted to show is I have the customer table, that's the users. And let's go back to data. I also have line items. This is stuff that everybody has bought. And this is connected to, let's see, the ship date as well as order. And then if you look at orders, then order is connected to customer. So a customer, I can see all the orders they've purchased. And then from the orders, I can see all the line items. Part is just the product that they have created. And the other thing that's pretty neat, I think, is I haven't tried it, is it says generate diagram. So let's try this. I haven't done this recently, but let's see what it does. Oh, there we go. So you get the idea. Can I make it bigger? Oops. Let's see. No, I cannot. But yeah, so this is one idea that I really like. The other thing I also like these days, and I'm trying to work it out, is I'm lazy, so I don't like to write all SQL on my own. So what I'm doing this is Cursor. And Cursor is, if you're not aware of it, it's an AI agent tool. And basically, you can ask it for any SQL or any questions, but you can also ask it to not only get the code, but also run it. So like I said, I'm lazy, so sometimes I would just go in and let me show you the history. Oh, maybe I don't have it. Anyway, so when I run the query, I get this. Now, what is this thing? Well, if you use Cursor or VS Code, you could just go to VS Code extensions and look for SQL tools. And then SQL tool will basically give you the different connectors. You then go in and say, I want a new connector. And it'll tell you, okay, which one? SingleStore, Postgres, CockroachDB, there are more. There's Mongo too. And then if I choose this, I go fill out the details and now I'm off and running. All right, but that's not what you're here for. You're really here for showdown between performances. Now, straight off the bat, I'll show you that here in SingleStore, I'm going to do select count star by orders, command enter. And this actually tells you what? 43 million rows. Now, when I tried to, so I first created it here in SingleStore, and then I tried to copy it over to Postgres or NeonDB. Off the bat, it failed because I think I tried it for like 45 minutes to load the data and it failed. And I gave up after a couple of couple of attempts. So let's do the same thing. If I say select count star from orders, same table, but it's actually a lot less data and it's taking its own few time. I know I have 10 minutes, so I'll try to, if Postgres helps me, I'll try to make it faster. Otherwise, you can see the recorded version where we'll just cut this off and just show you the final number. All right, so I'm still doing, this one here gave me 41 milliseconds. This one, just for a count, it's still going. And this one, again, like I said, it's 43 million rows. If I remember correctly, it was about a couple of million here only. Now, granted, if I created, actually, let's see if this is, okay, so this one is what, 3, 4, 5, 6. This is actually 22 million. So it's half. It's not as low as what I was thinking. And if I look at orders, let me look at the structure. Yeah, I don't have an index, which is fine. So When you want to run additional queries, you can run indexes or create an index by just going here, and it should speed up things, right? But those are again for frequent queries that you do, and it's mostly for read, not for write and updates. So now what I'm going to do is go through some real life use cases to see how we do if this was an application where it was doing certain things. So I want to now forget even this. What I want to do now is just do an average of the total price from the orders. So I'm going to do this in SingleStore first. It gave it to me right away. That's 93 milliseconds. And if I do this, it's going to be a lot worse, because remember what I said, that this is more of a OLTP database. So it's good with the point, read, and writes, but it's terrible if you're trying to run an average, or you're trying to do sort by or group by, or even do joins, which we'll see in a little bit. So this keeps going. While it's going, I want to come back here and do a little bit more complicated one. So I'm going to say count order and group by and order by the order priority. So if you look at the orders, there is something called an order priority as here. So there's order, which is 5 low, and so on and so forth. So I want to group it by this, but at the same time, okay, so this one looks at finished, and this one took what, 53 seconds. So about, 1 minute, versus this one we did in less than a second, lot fewer than less than a second. So let's just call it about 53 times slower for this one. So this one, I'm now going to just run this query 58 milliseconds. And I want to do the same. Now remember, the number of orders is also a lot less, like 50% less than here. And so is the number of customers. So I'm going to run this, and then again, we can go get a coffee while it goes and finishes that. Meanwhile, here, now I also want to go do query total sales for each year. So I'm going to say for each year, order it, count the total number of orders in that year, round it off, and then give me like total sales by adding up all of it. And then I want you to order it by the year and group it by the years too. So this one, my intuition tells me it's going to take longer. Oh, it did. Okay. So it tells me the order year, the order count, and the total sales. And that's also about 100 milliseconds. This one is still running the previous query. We are over a minute now. Okay, so that took about 57 seconds. Now I have a bunch of other queries too, but for the sake of time, I'm going to stop, because hopefully you get the pattern. And the pattern is that, what is this? Did I do something mistake? And I want to commit it. Tools. I think it's Command S. Okay, never mind. Seems like a bug with TablePlus. But you get the idea, right? So now I'll go back to here, which is my SingleStore, and then talk a little bit more about what are some of the other things that you could do. One of the things that we are working with is, I believe if you go here, you can now also load data. And the load data is, when I say load data, it is more visual now. So you could go in and If this doesn't show up for you, that's because it's in a private preview. Reach out to us and we'll enable it for you. But you can bring in data from your own CSV file. You can bring it from Kafka. There's several webinars that Akmal has done, which is really good. I would encourage you to go do that, because if you're looking to bring in streaming data and then combine with your existing 100 million rows and then do query, SingleStore is even better for that. And then you can also bring in data just like we did for TPC-H directly from Amazon S3 or other places. And oh, by the way, you can also do it from MySQL, MongoDB, and so on. Akmal, keep me honest here. Do we have a pipeline for Postgres? Because I did a hacky version where I opened it here and then I just exported and then imported from here.
I'm not aware of it. I mean, we do have the CDC, Madhuka, as you know, for MySQL and MongoDB. I think with the announcement of the acquisition recently, which you might want to say something about, that's going to be really awesome for us because of all the connectors to all these other external sources, of which I think Postgres is one of them.
Yeah, and the thing about that acquisition, we are calling that as Single Connect. With Single Connect, you can also bring in real-time data from Salesforce, from ServiceNow, and from SAP. So it also opens up your data, ingest from not just different databases, but also from different applications as well. So I'll stop here and I'll see if there are any questions.
Thanks everyone for joining. So we are now open for questions. So in case you have any questions, feel free to let us know about that. And meanwhile, Akmal, do you want to talk about the getting started on SingleStore notebook? Like how
Yeah,
can
just
people actually, yeah, like how you generally do during your webinars? Because we
yeah.
have some time.
Yes, so I think as Maruka showed, the notebook is a great way if you just want to try out a little bit of some of the sort of features and capabilities which Maduka talked about. So, for example, some standard SQL queries. We all want to run, average, some min, max, count type of queries. That's very easy to do. SQL supports those very easily. And then, of course, if you want to, say, work with a little bit of JSON data. So I think the example that I tried to build out in that notebook was it's a bit like an order system, okay? And then you might want to add some data that's available in a sort of a JSON format, perhaps some tracking information, and then you'd like ideally to get some sense where the people are that are ordering this. So you want a bit of geospatial, sort of information. I think they're all based in Canada, by the way. I sort of picked Canada and sort of cities across Canada. And then you might want to do a bit of time series as well. Just look at the different timestamps and be able to query based on those. So it's a very basic kind of introduction. Of course, the product is far more featured, and we've covered some elements of those in the past. And actually, just at this time, I'm revisiting some content I actually wrote a couple of years ago. So there's a very nice geospatial application I built a couple of years ago, which is actually modeling the London Underground. So Maduka mentioned we're not a graph database, but we can work with graph-like structures. So, think of a rail network, stations, segments that connect the stations. And then you have journey times, for example, and you might be interested in finding things like the shortest route, for example. So that is a kind of a graph-like structure which you can model directly within SingleStore very easily. And you can do these wonderful geospatial queries to say, okay, here is a particular location. I'm interested in what other things are nearby, and show me the nearest Pizza Hut, for example, or something like that. So all of that's possible as well. But the getting started one is a great basic introduction to some of the sort of key sort of multi-model capabilities that we have. And then, of course, within Spaces, Stroke Gallery, we've got lots and lots of other things as well. So if you're interested in some specific area, for example, let's say you want to work with JSON and you might be interested in Kai, which again, Maduka mentioned, that we have this compatibility with MongoDB, there's notebooks on that. And if you want to read in from S3 buckets, there's notebooks on that. And if you want something to help you to performance and debug, there's notebooks on that. So we've got a whole range of very useful tools, very useful notebooks that others have built as well. And then you can utilize those as well. It's a great place to get started and just try it out for yourself.
Thanks, Akmal. I actually, while you were talking, I thought that maybe we can actually do a webinar because this was a customer use case. I don't want to take the name of the customer that they were using geospatial capabilities of SingleStore, and actually, it was working very well. So I know that one customer was using this. So I was thinking that maybe we can actually partner up and we can do one webinar together on that, right?
Yeah.
So I think we don't have any questions. So thanks everyone for joining. And Madhukar, is there anything that you would like to mention?
No. Yeah, for upcoming webinars, we will be doing a lot more of how to build an application, like a full stack application, coming very soon, which will, we are building a starter kit for Next.js that will help you create like a full stack SaaS within a few minutes. If you're interested, stay tuned. We'll be doing that webinar as well.
All right. So thanks everyone for joining. Thanks so much, Madhukar, for taking out the time for this. And thanks, Akmal, for tuning in. And to our audience, thanks everyone for attending. Have a great rest of the day. Take care, everyone. Bye.
All right. Thanks. Bye.